Welcome to a deep dive focused on a fascinating stack of source material, exploring a period often skipped over in traditional accounts of scientific history.
That's right. We're delving into the golden age of Islamic science, shining a light on some incredible individuals whose work really built the foundations for disciplines we rely on today, but whose names might not be familiar to you.
Exactly. We've got figures considered the fathers of fields, from algebra and optics to, well, surgery and sociology. We're talking about names like Al-Khwarizmi, Ibn al-Haytham, al-Biruni, al-Zahrawi, Jabir ibn Hayyan, al-Tusi, and Ibn Khaldun. Quite a list.
And our mission really is to extract the essential insights from these sources, understand the scope of their achievements, and critically examine why their contributions were, in many cases, significantly overlooked or even written out of the Western historical narrative.
So, consider this a journey to rediscover an intellectual heritage and see the surprising ways these brilliant minds still influence your world today. Let's unpack this incredible material. Okay, first up, let's travel back to 9th century Baghdad. This was the heart of the Abbasid Caliphate, a vibrant intellectual hub centered around the House of Wisdom, or Beit al-Hikmah.
Right. A place where scholars from all sorts of backgrounds collaborated, translating ancient texts, yes, but also forging entirely new knowledge.
And it's in this environment, working under Caliph al-Mamun, who actively patronized science.
That's key. It's where Muhammad ibn Musa al-Khwarizmi made his mark. And he didn't just contribute to mathematics, he fundamentally changed it. Before him, a lot of math was tied to geometry, right?
Yeah.
Solving problems based on physical shapes.
Right, very concrete. So he introduced something completely different.
Precisely. He brought in this revolutionary concept of using symbols and equations to represent unknown quantities and solve problems abstractly. His big book, Kitab al-Mukhtasar fi Hisab al-Jawab wal-Muqawala,
That's the one.
was the first systematic approach to solving linear and quadratic equations using these new methods.
In the name of that book. That's where we get the word algebra, isn't it? From al-Jab.
It is, yeah. And al-Muqawala, the other part, referred to the idea of balancing equations. He wasn't just theorizing. He showed how to apply these techniques to practical problems like inheritance or land surveying. He really demonstrated the power of this new way of thinking.
So his work laid the bedrock for computational thinking. Things like computer science, engineering, economics.
Absolutely. Think about it. No physics formulas, no banking algorithms, no coding as we know it, without the foundations he laid.
So if you're working with code or analyzing financial data, you're essentially using concepts that trace back to him.
You really are. And his influence didn't stop there. He was instrumental in bringing the Hindu-Arabic numeral system, including the concept of zero, which was a total game changer to the wider Islamic world and eventually to Europe.
Zero seems so basic now, but it wasn't always there.
Not at all. And his methods for calculation, multiplication, division, they became standard practice.
And isn't his name also linked to another foundational concept in modern computing?
It is, and this is where it gets particularly fascinating. His name, when he was translated into Latin, became algorithmi.
No way.
Yes, that's where we get the word algorithm. The algorithm's driving everything today. Search engines, social media, AI. You can trace their lineage right back to this 9th century Muslim scholar.
That connection is just mind-blowing. He wasn't just a mathematician either, was he?
No, far from it. He was a noted geographer. He corrected and expanded on Ptolemy's maps, mapping over 2,400 locations with remarkable accuracy, developing early grid systems that kind of resemble early GPS ideas.
Okay.
And he did significant work in astronomy too, refining calendar systems, creating celestial models.
Given all of this, the root of algebra, algorithms, advances in geography, astronomy, why isn't Al-Khwarizmi a name every student learns alongside Pythagoras or Euclid? It seems obvious they should.
Well, that's a really critical question the sources get into. They point to a deliberate process, often tied to colonial and Eurocentric historical narratives. As European scholars started building on Islamic scientific works, the original authors' identities were often obscured, sometimes erased entirely.
So, like his name being Latinized to algorithmi.
Exactly. That meant later European readers might not even have known it referred to a specific person, let alone a Muslim scholar from Baghdad. And there were these Orientalist views that painted the Muslim world as just a preserver of Greek knowledge, not a place of profound innovation itself.
So they downplayed the original contribution.
Actively downplayed them, yeah.
Yeah.
This historical framing was quite intentional in many cases.
And why does knowing this history matter to you, listening today?
Well, because representation is powerful, isn't it? Understanding that these fundamental tools of modern science and tech originated partly or largely in the Islamic world challenges simplistic narratives. It can be incredibly empowering. Remembering Al-Khwarizmi isn't just about historical correction, it's reclaiming a rich intellectual legacy that was, frankly, intentionally hidden.
Okay, from the world of numbers and algorithms, let's shift focus. Let's look at how these scholars tried to understand the physical universe, specifically how we see. Moving into the 10th century now, we find Ibn al-Haytham in Basra, in what's now southern Iraq.
Another towering figure from that era, absolutely. Ibn al-Haytham grew up in a time and place where knowledge was deeply valued. He was known for this intense curiosity, always questioning established ideas, even from a young age.
And this questioning led him to write his most famous work, Kitab al-Manazir, the Book of Optics, around 1021 CE. And this was truly groundbreaking, wasn't it? Because it overturned centuries-old beliefs about how vision worked.
It really did. For a very long time, influential thinkers like Ptolemy, they had proposed that the eye emitted rays that allowed us to see objects. That was the standard theory.
It's hard to even imagine thinking that now. It seems so counterintuitive.
Right. But Ibn al-Haytham, through really meticulous experimentation using mirrors, lenses, even early versions of pinhole cameras, the camera obscura, he proved that vision works the other way around. He showed that light reflects off objects and enters the eye. The eye is a receiver, not a projector. Sounds simple now, but it was a revolutionary discovery.
And he used the camera obscura, basically a dark room with a tiny hole, to show how an image is formed when light comes through that hole. That's the fundamental principle behind every modern camera, isn't it?
It absolutely is. He also gave a really detailed and accurate analysis of the eye's structure, work that's still relevant for ophthalmologists. But maybe his most enduring legacy, even beyond optics, was how he formalized the steps of what we now call the scientific method.
Right. Observation, hypothesis, experimentation.
Exactly. Observation, hypothesis, experiment, analyze the results, draw a conclusion, and crucially, repetition. He emphasized experimentation and evidence over just relying on what ancient authorities said.
So he wasn't just discovering things, he was showing how to discover things reliably.
Precisely. He really pushed for empirical evidence. He famously wrote something like, "We shouldn't just accept what others narrate. It's our duty to question and investigate." That whole approach set a new standard for scientific inquiry, centuries before figures often credited with it, like Galileo or Bacon.
And he also worked on challenging the old Ptolemaic model of the cosmos and designed mechanical devices too, right?
Yes, he had wide-ranging interests.
So given his foundational work on vision and the scientific method itself, why is Alhazen, that's his Latinized name, right? Why isn't he universally known?
It's, again, what the sources point to as this systemic historical erasure. His name gets Latinized to Alhazen, distancing the work from his Muslim identity. His research was widely translated, heavily used by European scholars for centuries.
But without the credit.
Often without proper credit, yes. Or the credit was vague. This downplaying was part of that broader effort, especially during the colonial era, to frame Europe as the sole source of scientific progress. Plus, the decline of Muslim scientific institutions later on and the impact of colonial education systems within Muslim countries meant that even locally, knowledge of his contributions faded.
The impact today is still undeniable, though. Like you said, every photo you take, every science experiment relies on his principles or methodology. There's even a crater on the moon named after him.
There is. His story really reminds us that intellectual curiosity and rigorous science weren't just present, but they flourished in Islamic civilization. He shows that faith and rational knowledge can coexist, maybe even reinforce each other. His life is just a powerful example of questioning everything and seeking truth through evidence.
Let's turn now to a true polymath, Abu Rayhan al-Biruni. Born 973 CE, present-day Uzbekistan. I mean, this guy seemed to master everything: astronomy, physics, math, medicine, history, linguistics, fluent in Persian, Arabic, Sanskrit, Greek.
His intellectual breadth was just astonishing. Al-Biruni wasn't bound by borders or languages. His curiosity drove him to travel widely, famously spending a lot of time in India.
And his study of India was groundbreaking in itself, wasn't it, for its time?
Absolutely. His book, Tahqiq al-Hind, was this remarkably objective and detailed account of India's culture, sciences, religions, languages. He learned Sanskrit, studied their texts directly, and documented their knowledge with a level of respect and scientific detachment that was truly pioneering. He's often called the father of Indology for it. He was all about bridging cultures through scholarship.
And his purely scientific achievements, they were pretty stunning too.
Oh, staggering. He accurately calculated the Earth's radius using this clever geometric method, observing the dip of the horizon from a mountain. His result was incredibly close to modern values, centuries before similar calculations in Europe.
Wow.
And get this, he proposed the idea that the Earth rotates on its own axis. And he even discussed the possibility of heliocentrism, the Earth going around the sun hundreds of years before Copernicus really pushed it.
He was thinking about the Earth spinning and orbiting way back then, when that was definitely not the mainstream view.
Not at all. He also made huge advances in trigonometry, developing functions like sine, cosine, tangent, in a form we'd recognize today. And he applied these mathematical tools to explain physical phenomena, sort of paving the way for mathematical physics.
So he wasn't just calculating, he was using math to model the world. Given this incredible range, his accurate Earth calculations, his thoughts on Earth's motion, his foundational work on India, why is Al-Biruni not a household name?
Well, it's that familiar pattern we keep seeing in the sources. Eurocentric historical narratives, especially after the Renaissance and during the colonial period, consistently downplayed or just plain omitted contributions from non-Western scholars.
So his work was used, but maybe not credited.
Exactly. His works were studied, they were built upon in Europe, but often without credit, or his identity as a Muslim scholar from Central Asia got lost in translation or historical retelling. Plus, the destruction of libraries in various conflicts and maybe a decline in scientific funding in some parts of the Muslim world also meant his work became less accessible over time, even in his own region.
So what can Al-Biruni's story offer us today?
I think he stands as this powerful symbol, not just of intellectual excellence within the Muslim world, but also of the profound value of seeking knowledge across cultures, across languages, with objectivity and respect. He reminds us to keep asking big questions, stay curious, and pursue truth wherever it might lead. Reclaiming his name is about historical accuracy, sure, but it's also about inspiring people today with this rich legacy.
Okay, from the vastness of the cosmos and cultural studies, let's zoom right in on the human body and the world of medicine. Let's talk about Abu al-Qasim al-Zahrawi, known in medieval Europe as Albucasis. We're in 10th century Al-Andalus, modern Spain, specifically Cordoba, which was this incredibly advanced center of learning, especially compared to parts of Europe at the time.
Cordoba was definitely a shining light in the Islamic Golden Age.
Yeah.
Huge libraries, centers of learning. And al-Zahrawi was a physician there who spent, get this, 50 years practicing and documenting his medical knowledge. He essentially transformed surgery from, well, a pretty basic, sometimes brutal craft into something resembling a scientific discipline. His life's work was this massive 30-volume medical encyclopedia called Al-Tasrif.
30 volumes, and it was the surgical volume that was really revolutionary.
Absolutely. It was the first comprehensive illustrated manual on surgery. He described procedures in detail, but crucially, he designed and illustrated over 200 surgical instruments.
200? That's amazing.
It is. Scalpels, forceps, cauterizing tools, speculums. Many of which are remarkably similar in principle, maybe not in material, but in principle, to instruments used today. He didn't just describe them, he showed how to make them and how to use them properly.
Incredible. What other techniques did he pioneer? Things we take for granted now.
Well, he was the first to describe using catgut for internal stitches.
Because it dissolves?
Exactly. The body naturally absorbs it, so you don't need a second surgery just to remove the stitches. Game changer. He described using forceps to assist in complicated childbirths. Centuries before that became common in the West. He developed techniques for removing bladder stones, setting fractures properly, even procedures like tonsillectomies. And he didn't just focus on the cutting. He emphasized things like cleanliness, preventing infection, and even the importance of the patient's emotional state and good post-operative care.
The sources also mention his approach to medicine was deeply rooted in his Islamic faith.
Yes, definitely. He saw knowledge and the ability to heal as a trust from God, from Allah, and practicing medicine as a kind of sacred duty. He wrote quite a bit about the ethical responsibilities of a physician, stressing things like being God-fearing, humble, honest, pious.
So an early advocate for medical ethics, too. Warning against greedy doctors, treating the poor. It sounds like his worldview just seamlessly integrated science, faith, and ethics.
It really did. So the question then becomes, how did a figure who literally wrote the book on surgery for his time, whose instruments and techniques were used for centuries, just fade from common knowledge?
Is it the familiar story? Latinization and erasure?
In large part, yeah. His name gets Latinized to Albucasis.
Yeah.
His books become standard medical texts in European universities for hundreds of years. So students are learning from Albucasis, often without knowing the original name or the author's identity. And again, you have that Eurocentric history writing systematically downplaying the role of non-European civilizations. Then add colonial education policies that actively suppressed local knowledge and history in Muslim-majority lands. It meant people started to lose touch with their own intellectual giants, like Al-Zahrawi.
But his legacy is still felt, isn't it? Every time a surgeon makes an incision or uses a modern version of one of his tools.
Absolutely. His work was this vital bridge, preserving and advancing surgical knowledge when it might have otherwise been lost or stagnant. His story is just a powerful demonstration that faith, scientific innovation, and strong medical ethics can and did flourish together.
Honoring him means acknowledging that legacy, supporting future generations in medicine, and recognizing the incredible depth of contribution that came out of places like Al-Andalus. Okay, let's move on to another field entirely, chemistry. And here we've got Jabir ibn Hayyan, known as Geber in Latin, born way back around 701 CE, often called the father of modern chemistry.
Jabir was truly remarkable. A polymath, again, an alchemist, yes, but also very much a chemist, a philosopher, astronomer, engineer, physician. He was incredibly prolific, thousands of treatises attributed to him, really laying the groundwork for experimental science, especially in chemistry.
So if Al-Khwarizmi gave us the abstract language of math, maybe Jabir gave us the experimental language of chemistry.
That's a really good way to put it, actually. He systematically explored how matter transforms through processes like crystallization, distillation, filtration, sublimation, evaporation. He wasn't just mixing things randomly, he was trying to understand what was happening, the principles behind it.
And he discovered and created some seriously important substances, right?
He certainly did. He developed strong acids like hydrochloric acid and nitric acid, and perhaps most famously, he created aqua regia, royal water, a mixture of nitric and hydrochloric acids powerful enough to dissolve gold. These were revolutionary compounds for the time.
Wow. And he also invented crucial lab equipment, things we might still recognize.
Yes, absolutely. Beakers, retorts, alembics for distillation equipment that became the standard toolkit for chemical investigation for centuries. Think about that, designed over 1,200 years ago.
His emphasis on systematic experimentation seems like the really key thing here.
It is his core legacy for modern chemistry, I think. He moved the practice away from purely mystical speculation towards empirical observation, careful measurement, and detailed documentation. He really transformed alchemy from just a philosophical or mystical pursuit into something that started to resemble a scientific discipline, precisely because he insisted on repeatable experiments.
And his work eventually made its way to Europe.
Definitely. His works were translated into Latin, starting around the 12th century, and they had a profound influence on later European scientists. People like Roger Bacon, even Robert Boyle, who's often called the father of modern chemistry in the West. But Jabir was defining many of the basic practices and substances centuries earlier.
So the question arises again, doesn't it? Why isn't Jabir ibn Hayyan's name universally recognized as the founder of chemistry in every school textbook?
Yeah, it follows that pattern we've been identifying. Colonial-era historians tended to minimize or ignore contributions from outside Europe. When his works were translated, his name was Latinized to Geber. Sometimes this made it unclear it was the same person, or it even led to claims later that Geber was a completely different, possibly European figure.
Oh, really?
Yes. And that Orientalism played a role by often portraying Islamic intellectual pursuits as purely mystical or philosophical, not genuinely scientific. And sadly, again, internal decline in some Muslim societies and the imposition of colonial education systems meant that this history was often lost or suppressed within those regions too.
But knowing about him, understanding his actual role, offers a powerful counter-narrative.
It really does. It reinforces that scientific inquiry and deep faith can coexist and thrive. It shows that innovation isn't confined to one part of the world, and that Islamic civilization was this absolute powerhouse of scientific discovery. Learning his story can truly inspire young people, especially young Muslims, to see that STEM fields are not just something they can enter, but fields their ancestors literally helped create.
Reviving his legacy is an act of intellectual pride and, well, historical accuracy. Okay, next up, let's look at Nasir al-Din al-Tusi, born in 1201 CE in Iran. Another polymath, navigating life through some pretty significant political upheaval, the Mongol invasions, actually yet becoming one of the most influential thinkers of his time in mathematics, astronomy, and philosophy.
Al-Tusi was just a brilliant mind who managed to synthesize deep Islamic scholarship with rigorous scientific thinking. He really saw reason and revelation not as opposing forces, but as, complementary paths to understanding the world.
He made major strides in mathematics, didn't he? Particularly trigonometry.
Yes, he was a real pioneer there. He was the first to systematically treat trigonometry as its own independent field of mathematics, separate from just being a tool for astronomy. His work, especially in spherical trigonometry, was absolutely foundational for fields like navigation and, yes, still astronomy.
His trigonometric tables and methods were incredibly advanced for the era.
They were. And like some others we've discussed, his mathematical contributions were later used by European mathematicians who, sometimes presented them as their own work or didn't give full attribution.
He also had a major impact on astronomy, despite the turbulent times he lived in.
He did something quite remarkable. In 1259, during the Mongol period, he convinced the ruler, Hulagu Khan, to fund the construction of the Moraga Observatory.
An observatory under Mongol rule.
Yes, and it became one of the most advanced scientific institutions of the Middle Ages. It had sophisticated instruments, attracted a team of top scholars from across the region. They compiled incredibly accurate astronomical tables by meticulously observing planetary movements over years, far more accurate than Ptolemy's old models.
And he developed a specific mathematical model related to planetary motion that sounds very familiar.
Ah, yes. This is another fascinating connection. He developed what's known as the Tusi couple. It's this clever geometric model. It shows how a point on the edge of a small circle, rotating inside a larger circle that's twice its diameter, will actually move back and forth along a straight line.
Okay, so a circle moving within a circle can create linear motion. That's counterintuitive.
Exactly. It was a mathematical trick, essentially. A way to model certain types of observed astronomical movements using only combinations of circular motions, which fit the prevailing cosmology. And here's a really key part. Nicholas Copernicus, centuries later, used the exact same mathematical model, the Tusi couple, in developing his heliocentric theory. But he didn't acknowledge al-Tusi as the originator.
Wow. So al-Tusi figures out the specific mathematical tool, this geometric device, and Copernicus just adopts it without credit.
That's what the sources strongly indicate, yes. It's a pretty clear example of how sophisticated ideas flowed from the Islamic world to Europe, and how the attribution sometimes got, let's say, lost in translation, or perhaps conveniently forgotten.
And al-Tusi wasn't just a scientist, right? He wrote on ethics, too.
Correct. He also wrote important philosophical works like Nasir, which dealt with ethics, logic, and Islamic theology. He really blended rational philosophy with religious thought.
So a groundbreaking mathematician and astronomer builds one of the first major observatories, develops a key model used by Copernicus, and yet, again, relatively unknown in mainstream history. Why?
Depressingly consistent, isn't it? Post-Renaissance European narratives often wanted to establish this direct line from ancient Greece to modern Europe, minimizing or just omitting the crucial intermediary role and original contributions of Islamic civilization. Colonial suppression of local histories definitely played a part. The lack of widespread translation into European languages at that critical early juncture meant his work wasn't as integrated. And yes, instances like Copernicus using his work without explicit credit certainly contributed. His name and contributions were kind of systematically pushed into the background.
But his work really forms part of the bedrock of modern trigonometry and astronomy. His observatory model influenced later institutions. He was such a vital intellectual bridge.
He truly was. Reclaiming his story means recognizing that interconnectedness of scientific history and actively pushing back against those narratives that erased these crucial contributions. Including figures like al-Tusi in educational curricula is just vital for inspiring future generations and painting a much more accurate and frankly more interesting picture of human intellectual achievement.
Finally, let's look at someone whose focus was humanity itself. Ibn Khaldun, born in 1332 in Tunis. I mean, this guy was an absolute giant of intellect, considered centuries ahead of his time, earning titles like the father of sociology, historiography, economics, and political science.
Ibn Khaldun wasn't just a scholar sitting in a library. He was deeply involved in the world, a jurist, a diplomat, and advisor to rulers. This gave him this incredibly unique, practical perspective on how societies actually function, how states rise and fall.
And his most famous work, the Muqaddimah, the introduction, it wasn't just an intro to his history book, was it?
Not at all. The Muqaddimah, written in 1377, was revolutionary. It was a whole framework for analyzing history, society, economics, human behavior itself. It was like he was inventing new fields of study.
So he wasn't just recording history, he was trying to create a science of history and society.
Exactly. He's seen as the pioneer of sociology because he systematically analyzed social structures, the dynamics of group solidarity. He had a term for it, asabiya.
Asabiya. What does that mean, roughly?
It's often translated as group feeling or social cohesion or solidarity. He argued that strong asabiya was essential for a group, a tribe, or a dynasty to gain power and build a civilization. And crucially, he theorized about how societies and dynasties rise and inevitably fall, often linking their decline to things like luxury, corruption, and the erosion of that very asabiya.
So he saw the decline of that group feeling as a key factor in civilizational collapse. That's fascinating.
It really is. This kind of systematic analysis of social dynamics was just unprecedented. And he didn't stop there. He delved into economic ideas, discussing concepts like labor as the source of value, the role of taxation, supply and demand, long before figures like Adam Smith formalized them in the West.
And he had a particularly relevant observation about taxes, didn't he? Something still debated today.
He did. He explained how excessively high taxation could actually harm economic productivity and ultimately reduce state revenue in the long run, because it kills the incentive for people to work and invest. It's an idea very similar to the Laffer curve, centuries later.
He was analyzing things like optimal tax policy in the 14th century. Incredible.
He was. And in historiography, the writing of history, he stressed the need for critical analysis of sources, warned against bias, propaganda, and exaggeration. He set a standard for objective historical inquiry centuries before it became common practice in Western academia. He also studied the rise and fall of cities, connecting social behavior, leadership, economics, basically foreshadowing modern political science.
All of this deep analysis of complex societal forces, economic principles, historical method from the 14th century without modern research tools. How did someone this profound become so relatively overlooked for so long?
Well, it's that same pattern, intensified perhaps.
Uh-huh.
Western historical narratives, especially those solidifying during the Enlightenment, focus primarily on European thinkers, often bypassing the significant intellectual developments in the Islamic world that preceded and definitely influenced them.
So even if later thinkers used his ideas, they didn't credit him.
It seems so. Figures like Montesquieu or the historian Gibbon used ideas very similar to Ibn Khaldun's analysis of societal cycles and the impact of environment, but without citing him. Also, his works weren't as widely translated into Latin during that earlier critical period of translation compared to, say, the scientific works. So their integration into mainstream European scholarship was significantly delayed.
And the colonial factor again?
Absolutely. Colonial erasure intentionally downplayed the intellectual achievements of Muslim civilizations to assert European superiority. And again, the erosion of intellectual traditions within some Muslim societies themselves, coupled with the imposition of westernized curricula, meant that even people within those societies often forgot about towering figures like Ibn Khaldun.
But his ideas feel incredibly relevant, don't they? When you look at political instability, economic inequality, social divisions today.
They absolutely do. His analytical framework offers such powerful insights into the forces that shape societies, the importance of social cohesion, the dangers of corruption and unchecked power. He really shows that sometimes the answers, or at least the right questions for understanding modern problems, can be found by revisiting these brilliant minds from the past whose work was unjustly forgotten or ignored.
Reclaiming Ibn Khaldun means recognizing the astonishing depth of pre-modern social science and challenging those historical narratives that simply wrote him out. It means being inspired by his sheer ability to look at the complex world around him with such clear-eyed analytical power. Wow. What an incredible journey through these sources and the lives of these, well, truly remarkable figures. From Al-Khwarizmi giving us the very foundations of algebra and algorithms, to Ibn al-Haytham revolutionizing optics and formalizing the scientific method, Al-Biruni connecting global knowledge and calculating the Earth's size.
Yeah, amazing.
Al-Zahrawi establishing surgery as a real science. Jabir ibn Hayyan pioneering modern chemistry. al-Tusi shaping math and astronomy with things like the Tusi couple. And then Ibn Khaldun giving us the tools to understand societies themselves.
This deep dive, looking at your sources, has really brought to light not just the, monumental achievements of these individuals, which are stunning in themselves, but also the consistent, almost systemic processes that led to their names being obscured or erased from those mainstream historical accounts. It's a very stark reminder that the history of knowledge is complex, and it often reflects power dynamics just as much as pure discovery.
It really makes you pause and think, doesn't it, about what other crucial pieces might be missing from the historical narratives we've all been given, the ones we learned in school.
It certainly does. Understanding this history isn't just about, correcting the record for accuracy's sake, though that's important. It's about gaining a much more complete, more nuanced picture of our shared human intellectual heritage. It really opens our minds to the fact that brilliant insights and foundational discoveries have come from all corners of the world across vastly different cultures and time periods.
And for many people, perhaps especially young Muslims today, learning about figures like these provides such a powerful connection to a proud intellectual tradition. It shows very clearly that faith and the rigorous pursuit of scientific and philosophical knowledge have this long, shared, and incredibly productive history.
So maybe here's something to consider as you finish listening to this deep dive. If these were just some of the figures whose legacies were obscured, whose contributions were downplayed or forgotten, what other forgotten intellectual traditions or individual geniuses might still exist, waiting to be rediscovered? And could they potentially hold insights, perspectives, or knowledge that might help us address the complex challenges we face in the world today?